Hey, hello, and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem. Minimize the heights one. Okay, what the problem is saying is we'll be given a positive integer k and an array r denoting heights of towers. We have to modify the height of each tower either by increasing or decreasing them by k only once. We want to find out what could be the minimum possible difference of the height of shortest and longest towers after you have modified each tower. Okay, so what the problem is saying is here is an array and here are the towers given, the towers and the heights. Basically, these are the heights of each tower. Okay. And what we want to do is we want to modify the height of each tower either by increasing the heights, increasing or decreasing the heights by k. Okay. Okay. After you have modified the towers, whatever is the largest and the smallest tower, you want to find those different. You want to find the difference basically. Okay. And the difference should be minimum. You want to modify the height of the towers in such a way that the difference between the largest and smallest tower is minimum. So if you see in this example, so what will be the answer? Let's quickly see. So the first of all, what would be the modified towers? So the modified towers look like this: 3, 3, 6, 8. In order to find the minimum, right? In order to find the minimum difference between the largest and smallest towers, so we need to have the array in this way. So here, what it is done? So this particular 10, it is decremented by k, right? By k, right? This particular it is decremented by k. This particular 5, it is decremented by, sorry, here it is minus 2, right? It is decremented by k. And this particular 1, it is incremented by k plus 2. It is incremented by k. Okay. So after doing the operation, right? After doing this operation, it's your choice. Like you can decrement by 2 or increment by 2. But in doing so, when whatever are the largest and smallest towers, that difference should be minimum. So in this case, what is the largest tower? It is 8, and smallest tower it is 3. So 8 minus 3, we get 5, and we return this. Okay. So this is the problem. Okay, this is ask. Okay, which we need to solve. Okay. Now how can we solve this problem? So we are going to use one property, right? So what that property will be? So here, if you see, what they are saying is, first of all, we want to find the the difference. The difference should be minimum, right, between the largest and smallest towers. So for example, so when the difference will be minimum, when whenever the array, whenever the largest tower, if we decrement by k, right, if we decrement by k, which is minus 2, right, if we decrement by k, what it will be? What will give us? 3. Oh, sorry, 8. It will give us 8, right? And the smallest tower, if we increment by k, right? If we increment by k, which will give us 3. So whichever is the largest tower, right? So whenever we decrement, the point I'm trying to make here is whenever we decrement the largest tower by k and increment the smallest tower by k, right? So they will come closer, right? They will come closer basically, right? So, and hence the difference 8 minus 3, the difference will be smaller, right? Will be smaller, right? Because we are decrementing by k the largest and incrementing by k the smallest, and hence the difference, they will come closer, and hence the difference will be smaller, as opposed to this, right? As opposed to this, if we are taking just this and this 10 minus 1, I mean, we cannot do that. We need to modify. Or maybe if we are incremented this, or sorry, if we are incremented 10 by k, right, and decrement, definitely we cannot decrement this, right? Just a hypothetical case. For example, it was 3, right? If we decrement by k here, so it would have given us 1, right? From 3 it would have given us 1. So 12 minus 1, it would have been, the difference would have been 11, which was greater, right? And hence the approach would be, the idea would be to decrement the big towers by k and increment the small towers by k, so that those values will come closer, and hence the difference will be smaller. Okay, so this is the intuition. Okay, now let's quickly see. Okay, now let's see how we are going to solve this problem. Okay, so what we are going to have is, first of all, we'll have one, let's write it here, I think, one answer variable. Okay. Okay, so first of all, what we're going to do is, the thing is, this array won't be sorted. But in this example, it is sorted. So we are going to sort the array first. Okay, okay, okay. And what we, after sorting the array, what we're going to do? just for the answer purpose, what we're going to do, we're going to take the difference of the largest and the smallest tower. So, okay, so what it is going to be? 10 minus 1, 9. Okay. And then we're going to take certain variables like, let's take largest. Okay. So as I told, largest, what we're going to do largest? Largest will be the last element, right? The last tower, right? We are going to decrement by k. Okay, but which is 2, which will give us 8. And will be smallest will be this one, right? The first tower. Okay, we are going to increment by k, which will give us 3. Okay. And also what we're going to do is we are going to have um, we are going to have two variables, mi and additional. Like in addition to these variables, we are going to have two more variables, mi and ma. Okay, which will initialize with 0. Now these will be what? Like this will be to keep track of the minimum and maximum. Okay, let's see. Let's see now what we're going to do here, right? So we are going to start iterating from this particular tower, from the first tower, right? And what we're going to do is now we are going to find out the minimum between uh now we are going to have the minimum between the smallest, right? The smallest and and the what we're going to do here in this case, in order to have minimum, we are going to decrement the next tower's height by k. Decrement the next tower's height by k. So what we are going to do? 5 minus 2. Okay. Okay. So we are going to compare each time with the smallest, right? Smallest was what? Smallest is 3, right? And and we are going to compare by decrementing the next tower's height by 2. Okay, which will give us what? Which will give us what? 3 again. So smallest is already 3. So this will give us 3, right? This will give us 3. So why we are doing this? So see, now the next tower's height, definitely the next tower's height from the current tower's height, it is going to be greater because we have sorted the array, right? So what we are trying to do is we are trying to find the minimum after modifying the array, after modifying the towers, right? By either incrementing or decrementing. So the next element, for example, in this case 5, the height tower is greater than the current height, right? Than the current height tower. So what we are going to do? We are going to reduce it by k rather than incrementing by k, right? So we are trying to find the smallest, right? We have to modify the array, and since we want to find the minimum difference, and because the next hour's height is going to be greater, so what we're going to check here is by each time we are going to increment the current by 3, by k, and decrement the next tower by k, right? By k, in order to find the minimum difference, right? So here, so what we did, the next tower's height we decremented by 2, and ma, how we are going to calculate ma, it is going to be max of largest, right? And will increment the current heights tower, air of I plus 2. Okay. In this case, what is air of I? Air of I is what? Air of I is 1, right? So that's what we are comparing, right? What we are going to do each time, for example, this is the current, this is the next, right? Current next. So the element at this next position, it is going to be greater, right, than the current position. So what we're going to do in order to find the minimum difference, right? So we are going to increment by k, right, and decrement the next by k, so that these elements will come closer, and hence there can be minimum difference. Okay. So here r of I is 1, r of I is 1 plus 2, which gives us 3. So what it is, like max of 8 comma 3 it comes, right? Again, largest will be as is. So MA will have, so MI will have 3, right? And MA will have 8 only. Okay. And then what we are going to do? We are going to have, we are going to compare max of, right? Sorry, minimum we want, right? Minimum difference we want. So answer, we're going to compare with answer and this MA minus MI, right? MA minus MI we are going to do. So what answer holds? Answer holds 9, right? Which will give us what? MI will give us what? MA minus MI. MA is 8, MI is 3. So 5 it will give, right? Answer, what is the minimum? Out of 9 comma 5, it will be 5. And hence 5 will be recorded in the answer. So we can say 5, right? Let's do some undo in order to clear the dashboard. Okay, so you understood, right? You understood the idea. What we are doing here is, so what we did here is plus 2, right? That's what. Let this be. Okay, so answer currently is what? Answer currently is 5. Okay, 8 minus 3 we did, right? Okay, now let's go ahead. Now we come to this particular tower, right? We come to this particular tower. What we're going to do here is minimum of smallest. Smallest is already 3. We are not going to touch that. Minimum of mi equal to minimum of 3. And so current tower is this. So what we're going to do? Next tower, we're going to decrement next tower. That is air of I plus 1 with k. We are going to decrement, right? I've already explained this. Minimum of 3, comma 8. 8 next is 8, right? 8 minus 2. 8 minus 2, it is going to give us, sorry, 8 minus 2, 8 minus 2, right? It is going to give us 6, right? So minimum will be as is, it will be 3, right? Minimum was what? Comparison of smallest with the next hours decremented by k. Next hour decremented by k. Okay, so minimum smallest, right? So minimum is still 3. Then maximum is what? Max of largest. What is largest? Largest is 8 and the current tower is 5. So we are going to increment the current tower by 2. So 5 plus 2, right? Which will give us 7 again. Again, MA will be 8 only. Again, we compare answer. Answer equal to minimum of answer MA minus MI, right? So MA holds what? The largest tower and MI holds the value of smallest tower. After modifying, after modifying by K, either incrementing or decrementing. Okay. So answer is what? Answer is always 5, comma MA 8 minus 3. Again 5. So it will be answer will be 5, which will remain same. Again, we'll go to the next tower. What are we going to do here? What we are going to do here? So minimum, right? Mi equal to minimum. Smallest will be as is. We are not modifying smallest 3, right? But currently we are at 8. What we are going to do? So next hour we are going to decrement by k. So 10 minus 2, which will give us what? 10 minus 2 will give us 8. But 3, we compare with 3, it will give us 3 only. Ma max of, right? Max of what we're going to do? Largest. We are going to compare with the largest. So 8, comma, the current tower. What is the current tower here? 8. Current tower is 8. Okay. So 8 plus 2 we are going to do. 8 plus 2 we are going to do. Right. So, so 8 plus 2, yeah, the maximum what we are going to get here is 10. Right. So max MA will be updated now to 10. Right. Because 8 plus 2 is it's greater. Okay. So then what we're going to do? 10 minus 3 we are going to do. And we're going to compare with answer. So 10 minus 3 is 7, which is greater than 5. So we won't touch answer. It will be 5 only. It will hold 5 only. Okay. And here we are going to stop. Here we are going to stop. So at each step, what we are trying to do is, this is current, right? I think I hope you've understood this. And this is next. At each step, right? We are going to iterate the array and we are going to decrement the next with k and increment the current with k in order to find the largest, the new largest and smallest. And in doing so, these numbers will come closer and hence the possibility of minimum difference will be greater. Okay. So this is the intuition behind solving the problem. Okay. Okay, so this is the intuition behind solving the problem. I think you'll understand better with code. Okay, so before going to the code, if you've understood the solution, and I think you'll understand the code as well. Okay, so before going to the code, I'll request you to please subscribe to the channel, like the video. Okay, let's quickly go to the code. So what we're going to do here is, as I told, right? So we are first of all, let's have add.length into n. We are going to sort the array, sort the array. Okay. And then what we're going to do? First of all, we are going to have an answer air of n minus 1 minus air of 0. Okay. Then int ma, right? Int ma equal to, sorry, int ma equal to 0, int mi equal to 0. Okay. And then we want to have largest, right? Largest equal to air of n minus 1 decremented by k in smallest array of 0 incremented by k, right? And then we are going to iterate through the array I equal to 0, I less than n minus 1, since we are comparing with, since we are using the next element as well, right? And then what are we going to do? So mi equal to math dot minimum smallest, okay? And the next tower we are going to decrement by k. That's what we have explained, right? Minus k and ma equal to math dot max. We want to have the new smallest and largest towers, right? Largest comma array of I. The current tower we are going to increment by k. Okay, the current tower we are going to increment by k. And what we're going to do here is answer equal to math dot minimum we want, right? Minimum answer comma ma minus mi. This is it. Return answer, and we are done here. Okay, let's compile this. Let's quickly see what will be the time complexity as well. Okay, let's submit. So time complexity is going to be O of n log n, because you have sorted the array. Then we are iterating through the array which will take O of n. But here we are going to take maximum whatever it was required. So it is the time complexity is O of n log n. And the space complexity is O of 1. We are not using any extra space. Okay. So all the test cases are passed. I hope you have got the solution. I'll request you to please subscribe to the channel, like the video. Let's quickly see the C++ code as well. Not much difference here. So what we're doing here is we are taking the array size into n. We are sorting the array, and everything is same, not much difference. Only the difference is minimum and maximum we are taking from the standard namespace. Okay, so this is it. I'll also attach the code in the comment section. Thanks for watching. Don't forget to please subscribe to the channel, like the video. Okay, have a happy, healthy and a great day. Thank you so much.